Sweet, so I'm going to go over how to QC a fiber reel with these FAS Blue OTDRs, these fiber testers. So let's go ahead and dig right in. So these kits, they come in nice cases. You have two products. You have the reader, which is on the left, and then you have the transmitters on the right. So the transmitter has two spigots, and get in close there. And the one spigot is for 850 nanometer light, and the other is for 1300 nanometer light, and we'll explain those differences in a second. Then on your reader, you have one spigot which is covered up with a cap. If you pull that cap off, it is just a hole that you stick the fiber in. So it's pretty straightforward. So with these testers, they recommend that you turn them on and let them cook for about 5 minutes. So through the magic of TV, we have already done that. And then inside of your kit, you should have a ST to SC cable, because the generator is an ST connector, and then you need an SC barrel to test SC fiber or whatever fiber you're going to test. So notice we do have the caps on the fiber in the case, and then the barrel has the female cap there. So let's go ahead and set this up. So what we'll do is I'll put my testers here. They have a nice little kickstand, which is good. So I can flip that out. I can grab my fiber ends. And what I'm going to do is this test sheet, I'm going to notate the dBm reading at 850 nanometers for each strand. So what dBm is it is an absolute measure of basically what 1 milliwatt of light is at that wavelength. So in the documentation and in the lower third of this video, you'll see what that value is. And what we'll do first is we'll test the 850 nanometer light source. So on your light source, you have two sources. Only one works at a time, and these buttons down here, which this Greek character stands for wavelength. And you can basically go from one light source to the other just by pushing which one you want to use, and the LED indicates which one is generating. So what we'll do is we'll do 850 nanometers first, and the process is the same for 1300. We'll just save that for later. So we'll take our cap off after fighting with it for a bit. Then we will uncap our ST connector. We'll insert it, line it up, lock it in, maybe. And then what we're first going to do is, with our reader on, we're going to go to dBm. So we're going to make sure we're at 850 nanometers and we're in dBm. And the way you change that is your dB button would go between dB and dBm. We want to be in dBm, and then our wavelength needs to be at 850 nanometers. So as we push the wavelength, it's going to change what wavelength you're reading. So we'll go ahead and select 850. And the first thing we'll do is just make sure this is working properly by taking the cap off, literally covering it with our fingers and just making sure that it goes down, because we're going from an absolute measurement, and as we close the light off, our number should decrease. It's a negative number. So we'll see it go up a little bit because some light's getting in there. Now what we'll do is we're just going to get a baseline. We should see negative 17 dBm. And we're actually a little higher. We're actually closer to 0, which is due to just the light source just being slightly out of calibration. But what we want to establish here is, with a clean fiber, we're at negative 16.06. So we'll go ahead and remember that number, and then we'll hook up our reel. So we're going to test orange first. So we'll grab our orange strand, take our dust cap off, put it in the coupler, ensure it's connected well. While on the other end of the fiber, we'll grab our orange strand, take the dust cap off, just visually inspect, and you're probably unlikely to see it on the camera, but there is a little red light there. Let's see. Maybe. Oh, yeah, you can kind of see it. So what we'll do literally is just stick that end right into the cap there, and you can see that due to the length of the fiber, we've lost about 1 dB of signal. So this is within tolerance, and there's a sheet outlining what that is. So what we'll do is we'll take our pen, and we'll say for our orange fiber at 850 nanometers we are negative 16.994, and we're good to go. And then we'll repeat that process for each fiber. The one important thing to note when you're testing this is, as you get a reading, don't touch it. Because when you touch it and you move the fibers around, it's going to change the value on the reader, and you'll get a flawed result. But that's the process of doing it, and you know, if you need more info, reference the associated PDF, and you're good to go.